Hello and welcome to this new video. Just give me a second so I can check everything is fine here. I guess it is fine. Okay, sounds good. Okay, let's start. Let's show my face now. Hello, how are you? Let's put my face around here. Do I look good? I hope. Okay. I'm using headphones so I can listen better to the music or whatever we're listening to. So this is how to be a better programmer, be a better person, be a better everything. Okay. So I was thinking, well, why would that be that I like the C programming language? Of course, previous time we deal a little bit of B, that I said that B was a actual probably a good successor to C, and the only one that I approved and I would invest my time on. So right now I will only invest my time in C or B, but I still prefer C for some things, and I still see the beauty in C. So I say, why? Am I crazy? Well, I say there's something in which C is better than all other programming languages. I figured that out today. That's the reason that I'm making this video. And that reason is because it teaches you how to think, how to code. So it makes you better. And it is like doing some sort of a thing in an old-fashioned way. For example, it is like building a home yourself instead of buying pre-built parts of the home, or building a table yourself instead of buying an IKEA table that you have just to put it together. So there is a beauty, there is a value in building the table yourself, and that is that feeling and that learning experience is unique and very valuable to you. Probably that's what I think, or what that's a way of express what I mean when I say that C is like a breath of fresh air for me sometimes. Sometimes it's hard to manage C, right? But I was thinking, if I was a child, I could have learned C like sooner, like when I was 10 or something. That would have been great. I haven't though, because, well, I didn't even have internet when I was 10. So, yeah, hard. Well, I learned it when I was probably 19 or 20. Yeah. And I had internet only when I was like probably 14. Well, I used to have internet before that, but it was like limited internet. Like you can only use an n number of megabytes before it runs out and you cannot do anything. I had that internet, but it was very limited. So I was just afraid of using it too much. But when I have like unlimited internet, like the one that we have now, that it's not charged by how much you use it, but how fast it is right now, right? Okay. So this, I'm starting continuing actually to the previous videos that I was making, but from now I will start talking more about how to organize yourself in the world of C, because the world of C is very similar to the real world. right? The real world doesn't come with libraries pre-built for you. And sometimes it comes, but only for some things. One of those can be like prepared food. But sometimes it's useful to know how to prepare your food, right? Okay, so, and the beauty actually working in C, or the characteristic, or the nice thing about it, depending who you ask, is you need something, okay, let me write it. Okay? Let me write it. Okay, sometimes you need to copy memory from one place to another. Okay, you don't know that memcopy exists. Okay, that's fine, I will write it myself for my own needs. It may be a bit slower than memcopy sometimes, maybe at first, but then you can learn to optimize that thing and make it faster. Instead of copying 1 byte at a time, you can copy 4 bytes at a time, or even 8 bytes at a time, because you know that you have an 8-byte architecture, which is 8 times 8, 64-bit, right? So say, well, maybe the machine, the optimal number of bytes to copy, of bits to copy is 64, right? So then you continue optimizing it and adapting it to you. It's like adapting, like, okay, writing C is like making your own brushes that adapt to your hand. And the paintings that get produced with that are unique because the brush was unique, made by you, to you, for your needs, and with your style, with your taste. Also, how good of a taste do you have, right? It's like when you pick clothes. I don't know how good of a taste I have picking clothes, but you know. So yes, I mean, if you can see, well, for example, here I will tell you what I do. For example, please check at this line. 4th line. If it's too small, I will make it a bit bigger. Okay. So I don't like every time I want to print something to the console, I don't like saying printf. It's too long, right? I prefer just saying O. Like output, just O. And you can see how I use it here, for example, here. Well, this is commented, but this is how I use it. Okay? Okay? And, you know, that's preprocessor. Some people don't like that. But some people don't like your drawings either. But you like them. Right? And if you can do this, why not? Right? Why not? And if you have good taste, why not? I really prefer that it comes with this than other languages also come with just O to output something, right? Okay. Let's continue analyzing the code. Here I was as you know, the spirit of this is competitive programming. So I'm not very good at competitive programming. I would say I solve the problems, but I'm not fast at it. But I am teaching myself competitive programming while sharing the journey to you. And on the process, I'm also learning how to write better C, how to think better, and how to be a bit more of an organized person. Because I think sometimes I behave less organized than what I really am. So I'm not really organized in practice, but sometimes I am. So that means in the spirit I am organized. So, well, should we solve another problem today? Well, I don't know. I mean, probably not a lot of people will watch these videos, and that's fine. In the same way, not a lot of people watch my Instagram content, but that's fine. You know what? Because a big reason of why I do this, well, a big reason is for other people to enjoy, but another big reason that I made this is that I want to do it. I enjoy doing this. This is my free time. I mean, I'll do it even if no one watches it. And actually, no one watches this because I'm new. I don't know how to optimize and all that. I was learning, but still, I don't do it for it. If people find this useful, find these even entertaining or educational, well, that's great. The things that I won't stop making these videos because no one watches it. I will continue making these videos because it's good for me to make these videos. It's like going out and so I really do it for fun. So I'm here because I want, right? It's like going out and walk or something you like doing. I know sometimes I don't think I have my guitar here, but maybe one day I can play the guitar for you. Or for me, if only I watch it. Okay. So, yes. So, this is like... It's not an strictly programming thing. This is more of a relaxing thing. A thing that you put in your TV or your phone or your laptop, whatever, and just relax watching it, looking at it. I hope so. Of course, I guess that most of people that would do it is people that kind of are interested in programming in some way or another. But sometimes that's not the case, because I've seen that some people just like to watch some stuff that they don't even understand, right? I mean, yeah, I've seen that a lot. I don't do that too often, but people do that. Well, that's fine too. If you're as long as you're respectful with work of others, right? What do you think about the music? Is this allowed? Is this music even allowed? The Simpsons Chill Drive. Wanna change? Should we change? I think it's fine, but we can go to lo-fi studio music. Let's just see. Hello world, love lo-fi. Looks fine to me. And these channels are big, right? Okay. Okay, let's see if we can find another problem so we can solve. So for that, if you can do this as well. You can do the same as I do. You can even, copy my solutions for the problems I make. That's fine. I give you permission. So let's see if we can find another not very hard problem that we can solve. So I think solving it in C tells that you are ordered, right? Yeah. So let me sort them by difficulty. So I have solved already the first 4. Let's go to the next, the 5th one, which is this. A domino piling. Time limit per test, 2 seconds. Memory limit per test, 256 megabytes. Input, standard input, output, standard output. Okay, am I ready? Would I be able to solve this? I don't know. But let's try. Also, the challenge here is to stay relaxed while solving it. Right? Sometimes I get too mentally obsessed with solving it. That's not good. Let's try to relax a bit more. Well, I haven't seen any of the problems I solve previously, so I am actually solving them in real time because well, otherwise I would be I would be cheating, right? That's not cool. Okay, it says you're given a rectangular board of n times n squares. You know what? Let's do something different. Recently I bought I don't know how it's, a digitalizer tablet. Let's try to draw with this. Maybe this helps us solving problems. Okay, let me move my microphone and let me connect this to my computer. Just a second. None of this is planned, right? It's connected. I don't even know if it will work, right? And it came with this. It is a low end or mid end kind of thing. It's not a pro because I don't even, the first time I'm using these things. But let's just test, right? Well, I actually think I have downloaded Krita. Krita, as I'm told, is an app that enables you to draw for artists. Well, I'm not that big of an artist, right? But let's see what can we do. I hope it works at first, but probably if it doesn't, well, we'll have to install drivers or set it up, whatever. Okay, this is a new setup apparently. Okay, I've used it in my other computer for like 2 minutes, so I think you go to new file, then custom document, is that animation, comic templates, design templates. Well, I'm not an expert at all. Or texture, I think it is. Okay, let's use a texture of this. Use this template. Let's see. Oh, it works. Hahaha. Woohoo. Well, I'm a beginner, right? But okay. So you say, well, why are you using this? Well, it's Control Z to delete, probably. Yes, great. Okay, let's make me smaller. So I can, or move me around here so I can see the colors and all that. Oh, this is great. Okay, so going back to the problem. I feel professional now. It says, you're given a rectangular board, m times n squares. Okay, we can draw that, right? Okay, let's see if I can draw that. Can I pick another color, probably? Should I pick white? Would that be better? I guess, right? Oh. Whoa. Well, you have a board? I'm left-handed, if you ask. Okay. And has... Where is the thing? Okay. Let's see. It has... Oops. Oh. Oh, if I click, I can move it. Oh. That's new. Sorry, I'm new at this. Okay. Okay, let's see. It has, like, let's say n times, wow, m squares, right? And of course we're talking about squares, right? So I think I bought this like 2 weeks ago, and this is the first time I'm actually using for something. This, I didn't buy it with this in mind though. I'm very bad. I guess this will be also a way of improving my tablet using skills. Okay, let's see. Wow, what the hell? Where is it? I cannot find it. Okay, here it is. I guess some of you are way better than me in this. But well, I'm trying. Not the best, not the best. But still. Kinda cool, kinda cool. Okay? So that helps, that certainly helps. I'm writing it. Okay, drawing it. Okay, you're given a rectangular board, m times n squares. Also, you're given an unlimited number of standard domino pieces. 2 times 1 squares, right? Domino. Okay, domino pieces. Okay, sounds good, sounds good. So let's see if I can draw a domino piece like around here. So a domino piece would be occupying 2 squares, and of course would have like dots or whatever domino pieces have, right? Well, probably I should choose a better thing to draw here. This one would be better, I guess. Let's see. Well, yeah, but it's too thick. How do I change that? Let me move this around here. How do I change thickness? Okay, okay, wait a say digital. Also need to tag brush preset. Is this the size of that? Let's see. Yeah, it is. Apparently, right? Okay, let's reduce it even more. Let's... $12. Yeah, a lot better. A lot better. Okay. But okay, let's continue. Sorry for that. Okay. So also you're given an unlimited number of standard domino pieces of 2x1 squares. You're allowed to rotate the pieces. Okay, you're asked to place as many dominoes as possible on the board so as to meet the following conditions. Each domino completely covers 2 squares. No 2 dominoes overlap. Each domino lies entirely inside board and it is allowed to touch the edges of the board. Find the maximum number of dominoes which can be placed under these restrictions. Input: a single line, you're given 2 integers m and n. Board sizes in squares. M and n are both greater or equal than 1 and less or equal than 16. Output 1 number, the maximum number of dominoes which can be placed. Okay, how can we solve this problem, right? So let's go back to Krita. So it says it will give us the size of a board, and we have to say what's the maximum number of dominoes that we can put on it. How to do that? Well, if you have a simple board like this one, like an even by even size, it's easy. Like you would only, for example, say and count here, like, well, around here will be 2 times 4 would be 8, and it's impossible to put more than that amount, right? But what if you have only 3, for example? Then you can like use this part to, like, vertical here 1 and vertical here another 2. So 3, 4, 5. But how do you calculate that? Okay, well, of course there is some algorithm that solves this in an elegant way, efficiently, and whatever. But I don't know that algorithm, and I don't plan to look for that algorithm. So that's what problem solving is. So how else could we solve this problem? Well, you'll have, you can have like perfect set of a squared, like subset of the board, and like a square board or whatever. The problem is when the one of both of the lengths, width or height, m or n, are not even. Because if they are even, say like 2 by 2, for example, like this, well, this is 4 by 4, right? But same. And if they are the same, you just multiply 4 by 4 and then divide by 2. So 4 by 4, 16, divided by 2 would be 8. That's correct, because, like 1, 2, 3, 4, 5, 6, 7, 8. But that's not the same in other cases. So how else could we visualize this problem in a better way in order to find some reduction of it, thus to find a simple and elegant algorithm? Okay. So the number of squares would have to be like the orientation of the most of the, I'm just guessing, right? I was just thinking the orientation of most of the domino pieces should be the same orientation as the board. Would that be okay? Would that be a good thing to assume? Yeah, because if it's not odd, it's odd plus. I mean, if it's not even, it's even plus 1 or plus or minus 1, right? Yeah. So we could probably assume that it is even, and then add whatever it's left, right? Yeah, for example, imagine you have like 5 by 5 or 5 by 4 even, right? So let's imagine that you have like, let's say, another column right here in which you have 4 more things. In this case, it's okay because you say, well, it's 2 more, right? You can still just do whatever, as long as one of it is even, it's okay, right? I think, right? Yeah. The problem is when both of them are odd. So for example, it's 5 by 5, like this. So how do you solve it now? Well, it will be like 20 with the above stuff without including the last row, 20, and then it would be like however many things go into, will be 5 divided by 2, which is 2, right? So if both are odd, we have to reduce at one of the sides to an even size, compute that, and then the last row will be like something, but we will find out what it is, right? Okay, let's do it. Let's do it. That's the algorithm I found. Is it correct? I'm not sure. I think it is. Will it pass? I don't know. But what I'm basically saying that it will solve the dominoes problem is I will write down my solution. First solution, or first solution, let's say, if both sizes are odd, then reduce one size, compute what fits there, and add the remaining size, the remaining row, right? Okay. So as always, we will start with the actual name of the problem, which is domino piling 50A. That's how it's called. Okay. So, domino piling 50A. Okay. Great. So we comment the previous problem, which was this. And we start talking to our friend, dear old C. Okay. So we call domino piling. Okay. Then we will check the requirements with more attention. Okay, it's less than 16 m and n. Okay, so we can use only one byte to store them, which we call U8. Sorry. M0 N0. Sorry, here is not semicolon, but just a comma. Okay, great. We call U18, which gets that input from the keyboard. Okay, let's start with M or with N. Okay, let's start with M. Okay, and the same for N. U8 in. It means input a U8, right? Okay, so we're getting that from standard input, which means the keyboard, right? Right. Okay, so you receive an input of 2, 4, which one is M, the other is M, and it outputs 4. Right? That's fine. Okay, great. Okay. Now I have to output whatever I think it should output. I should output that to standard output. But before doing that, I'll say number of dominoes. And it's okay, I guess, to have it at U8. I'm not sure if it will be enough, but that's fine. So here I have to check. So check if. How to check if a number is odd? Well, we divide it by 2, and if it has a remainder of 1, it's odd. It's odd, right? Okay, so if M modulus 2 and N modulus 2 if both are odd, we have to do something. We would say we'll create like m minus 1. Let's call it like that. I don't know how to call it. M minus 1. Which is 0. Okay. Is that okay? I guess it is. Then, what's the result? Well, the result is easy. The result is m minus 1 times n. Right? But this will have to be divided by 2. For example, let's do with 3 and 3. 3 and 3 are both odd. So it takes just 1, which will be 2. Makes it 2. Okay, so 2 times 3 is what? Is 6, right? So in this case, 2 times 3, 6 divided by 2 will be 3. But we have to add the last thing. Have to add. So say result plus equals. And how do we add the last thing? So we're working with m, right? We will have to add n divided by 2. Right? Because in this case, that's the size of the width. If m is the height, the n is the width, and we're already touching the height, so now the width is what defines how many pieces fits in the last row. So it will be width divided by 2. In the case of 3 divided by 2, as far as I know, is 1. In integer arithmetic or whatever it's called, is 1, right? So result, that's what result is. And we can also declare it outside here, so we can use it when it's not when both are not odd. So that's when both are odd. Okay, what if both are not odd? Only one is odd? Well, that's fine. Because for example, 5 times 4 is 20. Right? 3 times 4 is 12. Yeah, I don't know if this is okay, but let's just test it. Result. So our result will be, again, easy. Would be m times n divided by 2. I don't know if that's correct. We'll see, right? And that would be it. Is that easy? Well, I don't know. Let's see. We print the result, of course, right here. We save it. We build it. Can we run it from here? Okay, let's run it. 2, 4 returns 4. 3, 3 returns 4. So far, it returns the same as the example. Well, right? Okay, but how do I upload this? I cannot upload this? What do you mean? Let's see if I say submit. what happens. You're not allowed. Should I say start visual contest? Well, let's see. Oh, I'm not logged in. Is that why? I'm sorry, yeah, I mean... What? Problem set? We sorted by difficulty. Let's see. I guess probably it's because I was not logged in. Right? Yeah, I guess that's the thing. Nah. Yeah, now I can submit it. Okay. Sorry about that. So we'll submit it. This is episode 2 as this videos. So main.c. Would it work? Will it work? Submit. Right here. Accepted! Oh wow! Thank you! Digitalization tablet, whatever you're called. You helped me. Okay. I'm a problem solver! Oh, okay. Well, it turns out that my reasoning was right. And what can I learn from this? That you have to simplify it. Say, well, when it's not even, well, it's even plus 1. Or even minus 1. So, when both are even, when both are at odd, we say, well, to make it even, say minus 1, calculate for even, and then add the last thing. It's done, otherwise just calculate as normal, divide by 2. No problem. Because if you have one even number and you multiply it with an odd number, it becomes an even number. Right? And if you have an even number, then it's fine, it's cool. Well, at least it passed the test. So that's great. And I did it in C. And it wasn't hard. Now you'll say, yeah, but you didn't code these functions, these U8 in. Yeah, that's true, but I coded it in previous videos. You can check it right here. I had problems with that actually. Previously, I talked about that in the previous video. I think in episode 2 or episode 1, I guess, because I'm numbering the episode. I'm not really naming the episodes in YouTube, but I'm starting naming like internally for me, like 0, 1, and 2. These would be 2. So in episode 1, in the previous video to this, and I think I was talking about this. This is how I am getting the input. And there's a whole story in what this caused me headache. But headaches from the past are in the past. And now it works. And now it helped me to solve this problem really easily. Using as little memory as possible. Right? Of course you could use less memory, I guess. But it really uses very, very little memory. I mean, 2, these are only 16 bits here. 24 bits. And the rest is just operation. Well, 32 bits with this one. And the rest is just operations. And of course we can simplify this even more. Instead of... we don't even need these variables, because we can move this inside here. Right? Okay. Right? That would be an even simpler version. It would use only 24 bits in variables. 24 bits in variables, right? Which is 16 plus 8. And that's how you do it in C. But of course the hard part goes not in C but in your mind. So you're finding the actual right solution for the problem. Yeah. So that's it. Another day, another C function that solves a problem. Let's enjoy the music a bit. Celebration. And I tried to stay relaxed. I don't know if I was, but I tried to. Yeah. If you're asked what I'm using, well, I'm using Qt Creator. You can use either GCC or Clang. Both are good. I use Clang more often than not, but yeah. So I think this is a fresh way of writing software, like producing on the most simple language in Linux. It's just fresh air for me, I guess. I guess I'm an old man, right? Okay, I think the music says we have to finish this video. Thank you for being here. Have a great day. Bye.